have a look at a past paper question. First one's got to do with volume. So we have a look at question 1. It comes from last year's prelim, Gauteng's prelim, paper 2. It says, Mr. Botha, the owner of the flat where Sakile stays, wants to build a fire pit in the backyard. He searched the internet, I see there's a typo there, and got the idea as indicated in the picture below. So here's our fire pit. We can see they've given us some dimensions and they are in feet and inches. So we know whenever we see that, there's going to be some conversion involved before we even get to answer our questions. But now remember, when we are going from imperial to metric or metric to imperial units, we're always given conversion factors, which have been given to us over here. Okay, so they told us 1 foot is 30,48 centimeters. Tell us what 1 inch is and what 1 gallon is. So the first question asks, determine the radius of the fire pit in centimeters. Okay, what do they mean by radius? Kia, did you see the comments?
Yeah, I'll answer now.
Okay. So half of the diameter, thank you. So if we are looking at a circle, because I've seen a lot of papers in my lifetime and we always get confused between radius and diameter. Diameter is from one edge of the circle to the other edge. So radius is from halfway to the edge, half of the diameter. Okay. The diameter of this fire pit, however, is 4 feet. So before we're going to worry about working out the radius, I'm going to ask you guys to quickly do that conversion for me. Please convert 4 feet into centimeters. Let me know your answers once you've got them. Convert the 4 feet into centimeters. Great, fantastic. Seeing the correct answers coming through here. Okay, so we're going to use the conversion factor given to us over here. They tell us 1 foot is equal to 30,48 centimeters. So if we know what 1 foot is, to work out what 4 is, we times by 4. We take the conversion factor and times by 4. And I see most of you did get this answer. Okay, so now we have converted the diameter to centimeters. Now we need to work out the radius. And as you guys said, radius is your diameter divided by 2. And I see you guys are ready with the answers. Good. Which gives us 60,96 centimeters. As you can see, that question was for 4 marks, so it's important to show all your working out. The first mark was showing the conversion, getting your answer in centimeters, dividing your diameter by 2, and getting your radius answer. I think that's easy 4 marks. Okay, so now keeping that in mind, question 2 says, determine the volume of the fire pit in centimeters cubed. You may use the following formula. Okay, so P is pi. I don't know why that symbol changed there. Times radius squared times height. And pi is going to be 3,142. So they've given you the formula. I just want to make you guys aware in this picture, the 12 inches mentioned here, that is the height. So the height is 12 inches. You need the height for this next question. I'm just going to rewrite the formula quickly. Volume is equal to pi r squared times height. And remember, we use 3,142 for pi. I'm just going to remind us here as well, height is 12 inches. So we've got the radius, we've just worked that out. So now we just need to work out the height, and then we can use the formula. Okay, so first step is let's convert the height to centimeters using our conversion factor at the top here. What do we get when we convert 12 inches into centimeters? Well done. Okay. So reason why I'm converting the height into centimeters is because we need all the units to be the same in the formula. Okay, so height is in inches, so we're going to convert to centimeters. So we times by the conversion factor, which will always be given, and we get a height of 30,48 centimeters. Okay, so now that you have all the dimensions and they're both in centimeters, I'm going to ask you guys to quickly work out the volume for me. Give you a couple of minutes. Well done, Oratile.
Oratile is constantly on fire. Constantly. Love that.
I haven't seen the answers coming in. Nice, well done. Okay, so all we have to do now is just put all our values into the formula, substitute into the formula, and we get an answer of 355,886,13, and don't forget our unit, centimeters cubed. Okay, again, that was for 4 marks. So first mark would be converting your height to centimeters, 2 marks for substituting into the formula, and your last mark for your final answer. Okay, well done. You guys are doing really well with these conversions. Okay, so just a reminder, we are looking at this fire pit. Okay, it is circular in shape. Question 3 asks us, what is the formula used to calculate the boundary around the circle? Choose the correct answer from the options given below. What formula is used to calculate the boundary around the circle? What do we mean by boundary around the circle? That's the perimeter of our circle or the circumference. Nice. Okay, so which formula do we use to work out circumference of a circle? Okay, so just, I don't know why this app keeps changing my pi symbol to P. So whenever you see P, it is pi today. So the first formula is pi times d. Pi, the next one's pi times radius. An area of a circle is pi times radius squared. Okay, great. So our answer is indeed A. 2 marks for that answer. Well done. Question 4. Hence, calculate the circumference of the hole for the fire pit. Round off your answer to 3 decimal places. Calculate the circumference of the hole for the fire pit. Round off your answer to 3 decimal places. So we said circumference is equal to pi times d. We did work out the diameter earlier. The 121,92. So it is 3,142. And that gives us an answer of, let's see in the chat. Nice. Three, 8, 3. Oh, that's actually a good point, Ashley. 3 decimal places. Okay, so just quickly, it was 383,0726. Because we round to 3 decimal places, we look at the third place after the comma. So that's 1, 2, 3. So we're looking at the 2. We'll always look to the right of the 2. Does it stay the same or go up? Because it's above 5, because 6 is above 5, it goes up to 0,73. So sorry, I said that the wrong way around. 0.073. Okay, so it's normally 2 decimal places unless otherwise stated, and they did ask for 3 decimal places in the question. Okay. Not a bad question. Let's try another volume 1. And I think the fire pit questions are really popular last year because here's another one. This one is from the Western Cape paper. So the Van Hart family plans to extend their braai area by adding a fire pit area. Okay, so they're giving us a diagram of what it looks like as well as the real life picture. In question 1, it says, identify the 3-dimensional shape that is indicated by the letter A. What shape, what 3D shape is indicated by letter A? So it's not 3D in the picture. What do you guys think? Nice. Okay, so it's not 3D in the picture, but we know that a circle 3D form that we work with is a cylinder. Okay, 2 marks. Nicely done. Well done. Okay, then the diameter of the fire pit seating is 400 centimeters. Write down the radius in meters. I'm going to give you guys a minute to quickly work it out. Find the radius in meters for me. If the diameter is 400 centimeters, what is the radius in meters? Does anyone want to tell me how they got that? Anyone feel like chatting to me? It's a nice, easy one. Oh, I'm getting different answers. Okay, so remember radius is our diameter divided by 2. The diameter is 400 centimeters. Divide by 2, which gives you 200 centimeters. We divide by 100 to get our answer in meters, which is 2 meters. Okay, well done. Let's have a look at question 3. The length of the fire pit seating is 3/4 of the circumference of a circle. Determine the length of the fire pit seating if the circumference of the full circle is 8,5 meters. So the length is 3/4 times the circumference of a circle. So how are we going to work out the length of this seating? So keyword again is of. Of means we are multiplying. Sure. Nice. Anyone else got the answer? So the length of the seating is 3/4 of the circumference. So we want to work out the length. They told us the circumference is 8,5 meters. So it's 3/4 times by 8,5. It's 3/4 of the circumference. And let's see if we get in the answers. Nice, guys. You're working really hard. Okay. Then another formula question. When they built the fire pits, they filled it with concrete. Write down the formula from the list below that they'll need to use if he wants to determine the amount of concrete needed. So remember, the concrete fills up the space inside the shape, so it is volume. And we are looking at a what shape? Fire pit is a circle, cylindrical shape. So we are looking at the formula for a the A, B, or C. Yes, okay, the C's have it. Volume of a cylinder, remember volume, the first one, length times breadth times height, that is for a rectangular prism or rectangular box. That's for a cube. And here is our volume of a cylinder. Okay, but again, you don't need to know these formulas off by heart. The most they can do is ask you a question like this in terms of remembering the formulas. Okay, well done. You guys are really powering through. Do we have any questions? How are we feeling about volume so far? If these 2 questions were in your exam at the end of the year, how would you feel? Good. Would we get 100% for these questions? Nice. Okay, that's good. So I know for the most part, most learners are quite anxious about volume and surface area. Okay, so now I'm going to look at a surface area type question. Quite a lot of information. Yes, we're just going to take some time to look at it. Terence displays his pot plant on a pot stand at the flea market. So he's got a stand that we can see on the right-hand side there. The first bullet point says the steel framed pot stand has a large square piece of wood, 30 centimeters by 30 centimeters at the base. So let's just highlight that. 30 centimeters by 30 centimeters at the base. So the base is the bottom. We've also got the measurements on the picture. And there are 3 other rectangular pieces of wood. That is also important information. 3 other pieces of wood, and they are 18 centimeters by 22 centimeters. So it's quite hard to see it, but it is labeled on the picture here. So that's why sometimes they give it to you in the question as well as the picture. So all the other 3, so it's this piece over here, this piece over here, and this piece over there, all are 18 centimeters by 22 centimeters each. All wooden pieces of the stand are cut from one piece of wood. The next bullet point tells us that the total height of the stand from the ground to the top of the stand is 92 centimeters. So the height is 92 centimeters. The height between the shelves on the left-hand side of the stand is also indicated. So we can see that in our picture. They've given us the different heights between the shelves. Okay, so the question is, calculate the total surface area of the wood used to make the shelves if the width of the shelves are 2,5 centimeters. You may use the formula. So you've been given the formula. We are used to the formula in this kind of format. Same thing. Okay, so we are wanting to work out the surface area of this shelf, as well as the base all together. Okay, so we know, for example, the base they are different dimensions. The base, the bottom piece is 30 centimeters by 30 centimeters. And remember, the width or the thickness of the plank is 2,5 centimeters. So I'm going to help you with the base part. We're going to work out the surface area of the base because of the different dimensions. Then the other 3, 1, 2, 3 shelves have the same dimensions, which are mentioned over there. Okay, so let's work out the base first. So surface area of the base is our 2 times 30 times 30 plus 2 times 30 times 2,5 plus 2 times 30 times 2,5. So the height is that little bit over there, which they said is 2,5 centimeters. So I've just substituted the 30s in plus the 2,5. The length is 30, width is 30, height is 2,5. If this helps, let's put it this way. Okay, I'm going to ask you guys to quickly work that out for me. Get some calculator practice in. Okay, nice. We've got 3 answers so far, and they're all correct. So if you put that all into your calculator, you should get an answer of 2,100 centimeters squared. So that is the surface area of the base. Okay, but now we need to work out the total surface area of all the shelves. So there are 3 other shelves. However, all these shelves have the same dimensions. Okay, so I'm going to ask you guys to work out the total surface area of those 3 shelves for me. Because they're all the same dimension, you could just do it once and times your answer by how many shelves we have. Let me know if you need some help. What a Tilly, I got a slightly different answer. What did you get for 1 shelf? Okay, so just check what a Tilly should be 2 times 22 times 18 plus 2 times 22 times 2,5 plus 2 times 18 times 2,5. I got in the 900s as my answer. So the 3 dimensions, just going to write them over here. Our length is 22, width is 18, height is 2,5. Actually, don't stress, just try your best to keep coming back. Maybe take screenshots every time you are here so you don't lose out. Kia also has a nice solution. But screenshots are your friend. Hey, do we have any other answers? Okay, 2972. I got 2976. I'm just gonna quickly check. Okay, Cowboy, we'll have to check when we go through it. I'm still getting a slightly different answer. Yes, Oratile, that's what I get for one shelf. Good. Yes, Ben, well done. Okay, so you got it right. Well done. Amor, I got 992. Okay, there we go. Typo. Okay, so you guys are actually getting this right. Maybe our fingers are just working too quickly. All right, so guys, let's just quickly go through this. Remember, surface area is working out the area of every single side of the shape. So this formula that's been given to us ensures that we are working out the area of every single side of these planks, the top, bottom, side, front, and back. We're working out the area of all the faces. Okay, so I'm going to work out the area of just the one shelf, and then I'm going to take my answer times by 3 because they're all the same dimension. Instead of doing this formula 3 times, we can just do it once, and then we times by 3 because they're exactly the same. So when we show working out, it is 2 times 22 times 18 plus 2 times 22 times 2, 5 plus 2 times 18 times 2, 5. And that gives you an answer of 992. That's for one shelf. So for 3 shelves, I'm going to say 992 times by 3, which gives me 2,976 centimeters squared. Nice. Thank you, Amor. Good. Okay. And now that we know the total surface area for the base as well as the other 3 shelves, we need to work out the final total. So we need to add those together. Please let me know what you get. Therefore, our total surface area good. Okay, well done. There was quite a lot involved in that question, but that's basically surface area, working out the area of every single side and then adding it all together. Depends on how many things you need to work out the surface area for. And again, you can see the formula was given to you. Okay, you guys handled that well. If you have any questions, let me know in the chat. But it seems like for the most part, we did understand it. Let's move on to question 4. So this also comes from a prelim from last year. Okay, so the 4 JoJo tanks are mounted on a concrete slab. The diameter of each JoJo tank is 1,820 millimeters. The concrete slab has a 50 millimeter allowance along the width of and the length of the slab, along the width and the length of the slab. Okay, so they've just given us information on how these JoJo tanks are spaced out on this concrete slab. Okay, so they told us the diameter of each JoJo tank is 1,820. They told us that there is a 50 millimeter allowance. So that 50 millimeter allowance are these arrows over here. So along the width and the length. Okay, and then on the picture, they've also indicated that the gap between the Jojo tanks is 100 millimeters. There's a lot of measurements given to us in the question as well as the picture. Now, just to include the diameter is in the circle from one edge to the other is 1820. Likewise, yeah, 1820. So that's pretty much what they've explained to us. So question 1 says, determine the length of the concrete slab in meters. So our concrete slab is this part over here. We want to know this length in meters. Does anyone know how we're going to try to figure this out? So I'll give you a clue. We know that the green parts, I'm going to zoom in a bit. Over here is 50. So for this little section, it's 50. Then I know this next section is 1,820 plus 100 plus 1,820 plus 100 plus, and so on. You're going to add all of these measurements up to get the length of this concrete slab. And once you add all of that up, then you can convert, or you can convert all of these before into meters. But because it's quite an easy conversion, you can just do it at the end. So you're going to take all of those measurements and add them up because they all make up the length of that concrete slab. Ben, I got a slightly different answer. I got 7,68. So Ben, in your calculations, do you have, so you've obviously added all the amounts together. Do you have 1,824 times, 50 millimeters twice, and 100 millimeters 3 times? Yes, Cabo. Nice shells. Anyone else? Okay, great. Okay, I'm going to explain now. Okay. Let's quickly erase. Okay, so we've got a picture that we are looking at the top of these JoJo tanks. So JoJo tanks are big cylindrical tanks that hold water. So we're looking at the top of them. And now these JoJo tanks, these water tanks, are being placed onto a concrete slab. Oh, I don't know what happened there. Okay. And they told us the diameter of each cylinder is 1,820. So that's from one edge of the cylinder to the other. In the question, they told us there's an allowance of 50 millimeters, and I've highlighted that in green. And they told you along the width and the length. So the 50 millimeters is over here, here, as well as there, and there. In the picture, they tell us, so the concrete slab starts over here. Okay, then there's 50 millimeters, then we've got our tank. Then according to this part over here, they're telling us that each tank is 100 millimeters apart. So it'll be 50 millimeters in the beginning, then we've got our tank. Then there's 100 millimeters, then our next tank, 100 millimeters, next tank. Then we've got the end of our concrete slab. Okay, so we're looking at from the top. We need to work out the distance from this edge to that edge. So all we do to work out the length of this concrete slab is take this 50 mils into consideration. So we can say 50 plus, then we know that the cylinder takes up 1,820 millimeters worth of space, plus the next bit of space is 100 millimeters. Based on this information given to us, then it's another cylinder, which is 1,820 plus another 100 mils plus another cylinder plus another 100 plus another cylinder, and we know the end piece is 50. Okay, so you're just adding up all those measurements together to get the full length of this slab, because they never gave us the length. So we can use these measurements because they're all next to each other, add them all up to get our full length. You could also write it out by saying 50 times by 2, because there are two 50s, plus we can take our cylinder measurement, 1,820 times by 4 tanks, plus there are 1, 2, 3 100 mil spaces. Whichever way you do it, you're going to get the same answer. It's going to equal 7,680 millimeters. We want the answer in meters, so we divide by 1,000, which gives you an answer of 7,68 meters. So it is quite a different way of asking, working out the length or the width, and it was worded a bit weirdly. But if you're ever given something like this again, when they give you a whole lot of measurements, this is probably what they're going to ask you to work out the length or width of something. Does that make more sense? Who was it? Amo and Oratile. Cool, perfect. Anyone else still not understanding? Okay, I'm going to ask you guys to look at question 2. Hence, determine the width of the concrete slab in meters. So now we're doing the same thing, but you're working out the width. So the other side. What is my width? Using the measurements given to us. If you want to take a screenshot, quickly do so now, because I'm going to erase my arrows and highlighter on the picture. Okay, let's see those answers. Ben, you gave me the length again. Yes, Koketso. Well done. Cabo, yes. Okay, so let's go through this. So I'm just going to zoom in. So we are working out the width. So that is this side through to this side. We know that this little section here is 50. We know this section here is 50. And we know that our diameter of the circle is 1,820. And that's all the measurements that go along the width. So to work out our width, we'll say 50 plus 1,820 plus 50, which gives us 1,920 millimeters. We want the answer in meters, so we divide by 1,000 again, and we get 1,92 meters. So I'm just going to zoom out so you can see the picture again. Okay, so the first part was identifying that gap there is 50, the bottom gap is 50, and then all that's left is the diameter of the circle. We add all those measurements up to work out what the length of the concrete must be based on those measurements.